Okay, so now what I'm going to do is I just mentioned that cosine is an even function. Definitely want to know this. This will be very helpful. What is an even function? An even function, which I know you all remember from algebra, is if f of minus x is equal to f of x. That means if for the variable you stick in a negative sign, it kills it off. This is true with cosine. You can't really prove that. Well, yeah, actually I can prove that by a heuristic argument, which is there's proofs in mathematics, like we just gave that sine squared plus cosine squared is equal to 1. That was more or less a real proof. There are heuristic arguments, which are just arguments by picture. You can prove, and most of you probably will if you go on, that cosine is an even function when you get to Cal 2, and that's kind of fun. What that means is that specifically cosine minus x is equal to cosine x. What's the picture of that mean? Well, that means that the cosine of minus pi over 2 is going to be the same as pi over 2, which is 0. The cosine of minus pi is going to be the same as cosine of pi, which is negative 1. The cosine of minus 3 over 2 pi is going to be the same as cosine 3 over 2 pi, which is 0. And the cosine of negative pi is going to be the same as cosine 2 pi, negative 2 pi, sorry, is going to be the same as cosine 2 pi, which is going to be 1. And now I'm going to do my best to draw this up here. And I'm also going to exaggerate here. This just goes on and on. These functions look like waves, and this is why they're so important. So much of what we do in physics has this character, and this has a very, very valuable representation, and we can use it for many things. And incidentally, I'm looking at my drawing, and it's not terribly brilliant here. I'll put this up. This is cosine x. Similarly, let's talk about sine x. Okay, so these you should know. If you know that cosine is an even function, then you'll know these. This basic picture from negative 2 pi to pi for sine and cosine, you really kind of need to know. This, let's see. I'll write this up. It turns out that sine is a odd function. So the sine of negative x equals negative sine of x. That means that if you put a negative inside, it ends up coming out. Some things that you need to know is that sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. And the sine of 3 over 2 pi, or 3 pi over 2, is equal to negative 1. And I'm getting out of room here a little bit. The sine of 2 pi, which I guess I'll put along here. The sine of 2 pi, now remember where 2 pi is on the unit circle. 2 pi is right at the starting point. 2 pi is the same as 0. So we're back here. So this is the same. Sine 2 pi equals 0. Let's see what this one looks like here. So when x is 0, this is 0. At pi over 2, it's 1. At pi, it's 0. At 3 pi over 2, it's negative 1. And at 2 pi, it's 0. So I'm going to do my best to sketch this in here. And we have this. And what do we know about odd functions? Well, odd functions behave like this. They also rotate around the x-axis, right? So let's do this. The sine of negative pi over 2. Well, pi over 2, sine of pi over 2 is 1, so sine of negative pi over 2, the negative will come out, it will be negative 1. And I'm just going to fill these in quickly as best I can. This is positive 1. So look at what we have here. These are nearly the same. As a matter of fact, what you can see is that they're shifted over. What you'll learn more is that they're shifted over by 90 degrees. But that will come to it. So Okay, so I want to explain more about the sine, cosine, and tangent functions. This is the unit circle. We call it the unit circle, of course, because the radial length is just 1. And sine and cosine, here's y, here's x. Remember that sine of whatever angle alpha is defined as y divided by the radius, but if the radius is 1, it's just going to be y. However, you won't always be using the unit circle, so I'm not, your book doesn't put this r down there, because when it's talking about the unit circle, it thinks you're going to know the difference, whether it's a unit circle or whether it's not. I will always put the r down there. You can just know that r is 1 in this case. I'm going to be over careful. Cosine of this angle alpha is x divided by r. And it would be helpful if we had an equals there. Equals x divided by r. And the tangent of some angle alpha, assuming that the angle is not pi over 2 or 3 pi over 2 or any variant of it, and I'll explain that a little bit more, is given by y over x, and this is actually equal to sine x over cosine x, but we're in alpha, sorry, didn't mean to drive you crazy. So that's what we have for now. What does it mean that we can't have pi over 2 or 3 pi over 2 or any variant of it for tangent? Well, look at what's going to happen. Tangent is sine alpha divided by cosine alpha. As this angle gets up, the x is shrinking down to 0, and or if we just put the angle down here, I suppose we could do that. This, the x value, the y value is going to stay it's going to get nearer and nearer to r, or 1 in this case. The x value is going to 0. So the first place that this is going to cause a problem is this is going to break up at pi over 2. Then it's going to break up at 3 pi over 2. Then it's going to break up at pi over 2 plus 2 pi. So basically, anytime we add 2 pi or subtract 2 pi, depending on where we went around the circle for either one of these, this is going to become undefined. And what this means is you're used to this, like the graph of 1 over x. Well, x cannot be 0, so this graph looks like this. This is actually a pretty unremarkable presentation of that graph. So the graph of tangent is going to have an infinite number of breaks in it. But now, there we go. I want to show you what the graphs of sine and cosine look like. And also, this is going to start to drive you a little crazy. We're usually going to do sine x, cosine x, and tangent x. And the reason is that x is the independent variable. And what we're going to do is we're going to take it off the unit circle, which we know is periodic, and we're going to straighten this line out like this. And I'll just put this up here. This is the x-axis now, AXIS. This is in radians. And this is a scalar. This is just some number, right? It's a unitless number, which is going to be the value of these functions. Generally, I would like you to know how to draw this graph relatively soon, because the basic values you're going to see show up all the time.